Hello everyone. Today I am honored to share with you my knowledge of data collection through single-board computers. The development of single-board computers has provided us with more possibilities and convenience. The existence of such boards makes scientific research a lot easier because the most important step in any scientific research or technological innovation is data gathering. Without data, there is no modeling, and without models, there is no way to apply and develop scientific theories. Today, I will introduce three common single-board computers. First, the Raspberry Pi, which is in this case here. Next, the Arduino Uno board in my hand here. And lastly, the Arduino Nano board, which is in the middle of this extension board. It's currently in the middle of a project, so I didn't want to take it out. Additionally, we will explore the similarities and differences between each board, as well as the usage and application of various sensors. From these sensors, we can collect data and apply them to scientific research and technological innovation. First, let's introduce Raspberry Pi. Raspberry Pi is a cheap yet powerful single-board computer. It was developed by the Raspberry Pi Foundation to promote computer science education.
Raspberry Pi uses an ARM architect and runs in a Linux-based operating system. It supports a variety of programming languages, including Python, Java, and C and C++. Thanks to its powerful processing system and intuitive interfaces, Raspberry Pi is widely used in education, home automation, IoT, and many other fields.
Next is Arduino Uno. Arduino Uno is the most popular single-board microcontroller in the Arduino series.
It is based on Atmel's AT-Mega 328P microcontroller. This microcontroller has 14 digital input-output pins and 6 analog input pins. It is simple to program and easy to use. Arduino Uno is used in a wide variety of subjects, such as electronic engineering, embedded system development, and various other DIY projects. It is worth noting that Arduino Uno does not support Python, because it does not have an OS, only an IDE which supports C and C++. Although the transition between Python and C should not be that difficult. Even if you are new to coding, C is a relatively easy language to learn. And pairing C with Arduino Uno is the ideal beginner-friendly microcontroller course.
Then there is Arduino Nano. Arduino Nano is similar to Arduino Uno, but is smaller and more suitable for scenarios with tighter space constraints.
This microcontroller is also based on the AT-Mega 328P and has similar functions to Uno, and the code between Uno and Nano is compatible. Because the Arduino Nano is powered by a battery, it is very portable. It can be used outdoors to collect data, such as the water quality of a river. Additionally, Arduino Nano is often used in wearable devices, portable electronic projects, etc., due to its compact size and low power consumption. An example is using the Nano board to monitor blood pressure for 24 hours a day, which is a lot cheaper than the 24 ambulatory blood pressure monitoring hospitals do.
Next, let's talk about the similarities and differences between a Raspberry Pi, Arduino Uno, and Arduino Nano. They are similar in that they can all be connected to various sensors to collect all sorts of useful data. These single-board computers all support programming and can be used for data transmission and remote control over the internet. However, there are also some significant differences between them. First, Raspberry Pi is a complete computer with great processing power and multitasking capabilities, suitable for complex computing tasks and application development.
Now, if we go onto our website, which is workfortuition.com, uh, we can see it'll retransfer us to this domain. Both of them work, but that one is easier to remember. And on this website, there are some past projects we do, and if we make new projects, we will also update our website. So back on topic, the differences between Raspberry Pi and Arduino. So the first example is our first place project in the recent Science Expo. We used a Raspberry Pi because it has a Linux OS, which allows user interfaces in real time, and it can display the data well, which would be harder on an Arduino Uno or Nano board. Arduino Nano and Uno are microboards, are microcontrollers, so they are better for sensor data collection tasks. So if we search up wearable projects like this, uh, things like oscilloscopes and other wrist devices, we can see that these use batteries because that would be more efficient. And secondly, Raspberry Pi uses an OS, so we search that up. For example, this, where the difference between an OS and an IDE is that an OS is able to view the internet and uh, run applications such as, since this is a Linux OS, it can run Linux applications, most of them, and an IDE, which let's show, this is the Arduino IDE. This is only able to write and edit the code that we want to run on our Arduino Uno or Nano boards. Now finally, Raspberry Pi has a higher power consumption, while Arduino Uno and Nano are more suitable for battery powered applications. Again, things like these. Let's go down like this. This is a heart rate monitor, and this is a battery powered application because it has low power consumption and batteries are more versatile than a power source.
Now let's introduce some common sensors and modules that can be used with our single board computers. In Aligu's 37-in-1 kit, there are 8 categories of different sensors or modules.
There are environmental sensors such as the temperature and humidity sensors, which can measure temperature and humidity levels in the environment. A thermistor module, which detects change in the temperature. A flame sensor that detects the presence of flame or fire. There are motion and position sensors, such as the passive infrared sensor, which detects motion through infrared radiation. Tilt sensors can detect changes in orientation or tilt. The vibration sensor senses vibrations and shocks. Hall effect sensors detects magnetic fields. Sensors that can sense light and sound include photoresistors, which can detect light intensity, sound sensors that can detect sound levels, infrared receivers that can receive infrared signals from a remote control. Proximity and distance sensors are also useful. Ultrasonic sensors can measure distances using ultrasonic waves, and infrared proximity sensors can detect objects within a short range using infrared light. The MQ2 gas sensor detects various gases like methane, propane, and smoke. Next, there are a variety of input devices, such as a joystick, a keypad, and buttons. Output devices include a LED module that emits light and an RGB LED that can emit different colors of light. Buzzer modules can produce sounds for alerts and notifications. Some other modules include a relay module that can control high voltage devices using a low voltage signal. potentiometers adjust resistance for analog input. 7-segment displays can deploy numeric information. LCD 1602 is a screen that can display alphanumeric information. Stepper and DC motor drives are motor drives that can control the motors.
As you can see, the 37-in-1 sensor kit offers a versatile set of components that can cover most development needs. Whether you're working on environmental monitoring, motion detection, light and sound sensing, proximity measurement, or creating interactive input-output devices, this kit provides the necessary tools to enhance your projects. Next, let us talk about the advantages of single-board computers. First, they are low cost. If we use an Arduino Uno board with the 37-in-1 kit, it would only be about $100, $60 for the board kits and $40 for all the sensors and modules. Although for the lessons, I believe we only need to buy the Aligu Super Starter Kit. Next, the data collection quality would be significantly higher than human gathering, due to computers being both faster and more accurate. I doubt humans could even record data every second. Additionally, the data collected by machines are more accurate. Computers can measure as little as 1.2 millivolts. I calculated 1.2 because the sensors of a Raspberry Pi can pick up upwards of 5 volts, and since it has 12 bits, 5 divided by 2 to the power of 12 is 0.0012 volts, which converted to millivolts is 1.2. Using a computer is also time efficient for the user, because while the computer gathers the data for us, we can work on other things. After the data is collected, visualization can also be done through softwares like Excel or Python's matplotlib. Now, let's talk about some real-life examples of collecting and analyzing data through sensors. My sister created zinc copper acetate batteries and needs to collect ampage data for an essay.
These are the pieces of equipment that were used in the experiment. A Raspberry Pi computer module with an extension board, the zinc and copper ends of the batteries wrapped around with paper towels to simulate the separator membrane. Vinegar or acetic acid acts as the acid of the battery. A temperature gun to monitor the temperature when heating the acid. Cups to contain the liquids, and a hairdryer to heat the solution. Let's watch part of the video she filmed.
Hi, in this experiment I'm going to investigate how different conditions affect the voltage of a battery. So here's the setup. First of all, this is the computer. It's connected to the monitor and it has the power and the mouse and the keyboard. And this is the breadboard where we put on the circuits on it, and there's 2 resistors that are 220 ohms each, and there's the chip that converts the voltage data into computer data. And this is the battery part, so it has the zinc and the copper. So first of all, I'm going to sand the zinc to make sure it doesn't, so to make sure it's smooth and it won't be like, won't have stuff on it that make the battery results different. And then I'm gonna put one piece of paper in between, to 1 paper length of distance in between the 2 plates. And then here's the vinegar, which is the acid, and it will provide the hydrogen ions. And then I'm going to do the first trial there will be 15 trials each. Each time we're going to measure different conditions, such as the space in between the two plates, or the putting two plates together, or putting two batteries together in parallel or series, or changing the temperature and changing the concentration of the acid by putting half of it with water, and also yeah, that's it. And so oh yeah, there's also changing the resistors by taking one of the resistors out. And yeah, so here is the first example. I'm going to run it and put the battery into the vinegar and then run the thing. Oh yeah, so you can see here the battery voltage has changed from 0 to 0.5 to 1 point something, and then back down. And these data are taken within 1 second, and we are going to find the average of it, and that will be the first trial.
Okay, now as you can see, this is the Raspberry Pi that is connected to a PC through a micro HDMI port, sorry. The single board computer also has an extension board. She connects the batteries to close the circuit and uses the input pins to measure the voltage. Now let's take a look at the code she uses to obtain the data. So this is the battery lab. And then she's the author. She did this for her Chem internal assessment for grade 12 IB. And there are 3 sections to it. There is a setup section where she establishes the connection between the Raspberry Pi pins and the modules. A loop section where the single board computer gets data 100 times while pausing 0.01 seconds in between. It writes the data into a notepad document after each iteration. Lastly, there is a destroy function that is initiated if there are any keyboard interruptions. This will close the ADC and stop the Raspberry Pi. These are the different states that the experiment can be done in. There are 3 sections, A, B, and C, where one is the normal default, one is in 80 degrees, which is heated up, and one is where the solution is a 1-to-1 ratio of water and acetic acid. In each state, the experiment is run 5 times, one with a single membrane battery and 2 resistors. The resistors are over here. One is here and the second one is here. This is the pins for the Raspberry Pi, and the battery, the homemade batteries that we made, are here. And here, when there is 3 layers of membrane, that would mean here 3 layers of paper towel. Here we are measuring the height of them to calculate the membranes. And with all of these experiments done, we have the data written into notepads, which is like this, one for each different experiment. And then we can visualize the relations between each data point by graphing it. And with all of this done, we can write our report. The report has 4 sections: an experimental overview, a experimental principle, experimental improvement measures, and a preparatory knowledge for understanding the experiment. For this experiment, my sister got a near perfect mark on her IB grade 12 Chem internal assessment.
We plan on designing a course teaching the basics of Arduino Uno with C. Because there are some offline in-person aspects, we plan on keeping the classes down to 4 students at most. The prices of the course will be determined with the counselor.